So in the first solubility movie, I talked about the general ideas of like dissolves like and unlike does not dissolve unlike, looking at like and unlike, referring to the interparticle forces, and how if there was too big an energy difference between them, then the process would not happen. So thus, for example, something with hydrogen bonding is not going to break those hydrogen bonds to dissolve in something that is completely non-polar. So in this movie, I want to just formalize that a little bit more, but then take a much closer look at the kind of like dissolves kind of like for ionic substances being dissolved in water. So anyway, all the way through, we're thinking about the delta H of solution. What is that heat change as the solution is made? And in much the same way, the delta H for a reaction is simply where you think about the energies of the bonds broken, the energies of the bonds made. Breaking bonds is endothermic, making bonds is exothermic, and put them together. Same thing here. The delta H of a solution is the IMFs that you have to break in the solute. You always have to break a few in the solution as well, but it's breaking them in the solute that is the really important thing, because just about everything gets broken in the solute as you have much more solvent than solute, minus the new IMF forces you're going to make in the solution. Now, like dissolves like means that the IMFs in the solute and the solution are pretty much the same. So therefore, the IMF in the solute is approximately equal to, maybe a little bit less than, the IMFs in the solution. In that case, delta H of the solution is either going to be exothermic, where the solution is greater than the solute, or slightly endothermic, when it's a little bit less than. Okay, so in other words, not very big energy change, or delta H, or if you do have one, then a definitely exothermic delta H. Now conversely, unlike does not dissolve unlike, are the situations in which the forces you have to break are going to be much, much greater than the forces that you make at the end. So the IMF in the solute much greater than the IMF of the solution. In that case, we can say delta H of the solution is very endothermic. In other words, this is much bigger than that one, so delta H is going to be positive. And then, of course, kind of like dissolves kind of like, you've got the same situation here. The IMF in the solute, IMF in the solution, either about the same, or the IMF in the solution greater than that in the solute, in which case delta H of the solution is again going to be either exothermic or slightly endothermic. Now, of course, when we're thinking about thermodynamics and energy changes, it's not just about delta H, it's also about delta S. And unless you're dissolving a gas, anytime you make a solution, delta S is going to be greater than 0. So let's take what we have here, delta S greater than 0 for sure, and then our various conditions with delta H. Well, in the first case, like dissolves like, delta G of the reaction, which is of course the combination of thinking about delta S and delta H, is either going to be negative for sure, because you got delta H exothermic, delta S positive, so nice and nice if you go back to the thermodynamic videos, or as long as the delta H nasty is not as nasty as the delta S is nice, delta G is going to be negative. And if delta G is negative, that means you have a soluble system. The system is going to be a spontaneous one in which you dissolve up the solute to make the solution. Opposite situation over here for the unlike does not dissolve unlike, because now you've got a very nasty delta H that is nastier than the delta S's, so that means delta G is nasty, delta G is going to be positive, thus it is a non-spontaneous process or insoluble. And then the kind of like dissolves kind of like, well again you're back to what we had up here. If the delta H of solution is exothermic, delta G is for sure going to be negative because delta S is positive, or if delta H is slightly endothermic, as long as the nasty delta H is not bigger than the nice T delta S situation. So again, we get delta G of the solution less than 0. It is going to be soluble. So that's just taking what we talked about 2 movies ago and putting the delta H, the delta S, and the delta G considerations to it.